right? If we have a graph, I have to use something that is not white, I guess. So if we have a general graph here showing this, right? We're looking at the temperature in degrees Celsius, and we're also looking at the dissolved oxygen, all right? And I don't know what units to use, but we're looking at dissolved oxygen, right? We're just drawing an arbitrary thing, right? So we're looking at the fact that we will have a graph that resembles something along like this. It slowly approaches zero, right? So it slowly approaches zero. So what we're saying here is that as temperature increases, right, the level of dissolved oxygen will decrease. So it's inversely proportional, right? So what's happening, as the water increases in temperature, we know that increases in kinetic energy, allowing the water, right, to move more vigorously in order for it to move vigorously, it would actually take up space, right? Because when something moves, it takes up more space than when it was by itself. I'm not saying that the water generally the water molecules. I'm not saying the water molecules get bigger, but the water in self well really expands, right? Things really expand when heated, right? Some physical terminologies, right? So we're saying that the water tends to take up more of the space of the excess or the free oxygen within the system, right? So when the water has more energy, right? For example, here in the graph. Wait, why is it? All right. So when it has more energy, for example, there in the graph, right, there will be less space for oxygen to stay within these pockets of water, right? So it's like an oxygen are separated are well surrounded by water. But as we heat the water, right, there is less space. It's encroaching on the space. You could think of it like that. So oxygen has to really be what's the opposite of dissolution? It's like evaporate or vapor. It's gonna be leaving the water, right? So we have that there. If it's cooler, right, generally you won't have such of a difference, right? Because remember that the colder water gets, right, water expands before it starts to freeze into the lattice. So since when water gets cooler, it expands. CSEC, well, not CSEC, Cape Biology Unit 1, it expands. It leaves room for oxygen. But as it heats, it actually breaks up those hydrogen bonds as it melts. And then as it gets hotter, it decreases the space between them. Remember that water expands as it freezes? Remember that ideology? Or that understanding? So we're saying that as temperature increases, there's going to be less room for oxygen to stay in. And if there's going to be less oxygen in, right, that will affect aquatic environments and aquatic ecosystems, right, and affect the biodiversity, right, based on the fact that a lot of our aquatic organisms respire aerobically, and if there's not enough oxygen, it's going to decrease fish populations, right? So it's something like that. I'm not sure if you get it, but that's better, right? I hope that it is a little bit better for you in that regard. That's fine. The person who asked for the explanation,
Yes, sir.
you sure?
Yes, sir. I did do unit one, but I understand what you're saying.